Next is decidability and halting problem. Okay, by taking Turing machine, I am taking the languages, 3 types. One is decidable language. Another is partially decidable, and the third one is undecidable language. Decidable language, what is decidable language? For decidable language, anyway there exists a Turing machine which will halt for some input, and if the string belongs to the language, definitely it will accept the string, or if the string not belongs to the language, definitely it will reject the string. Okay, if the string belongs to the language, it will accept. If the string is not in the language, it will reject. Okay, anyway there is a Turing machine which will halt for every input. Okay, that is decidable language. So recursive languages are decidable languages that we already discussed. Okay, so decidable languages means there exists a Turing machine which will halt for every input. If the input belongs to the language, it will accept the input. If the input doesn't belong to the language, it will reject the input. Okay, so such languages are known as recursive languages. Okay, then partially decidable language. What do you mean by partially decidable language? For partially decidable language, there exists a Turing machine which may or may not halt. May or may not halt. We can't ensure that the Turing machine will halt. Okay, if the string belongs to the language, definitely the Turing machine will halt. But if the string not belongs to the language, it will halt or not. That is not decidable. Okay, it is not decidable. May or may not halt. It may be halt or it may not halt. Okay, if the string belongs to the language, definitely the Turing machine will halt. But if the string doesn't belong to the language, we can't ensure that whether it will halt or not. That is partially decidable. That is, if belongs, it will halt. So partially decided. Okay, but it is completely not decided, because if the string is not in the language, we can't ensure that the Turing machine will halt for that input. Reject and halt and reject. Okay, so that is partially decidable. That is recursively enumerable languages are partially decidable language. Okay. Then undecidable language means there is no Turing machine for such a language. Okay, see, so decidable languages, a language is decidable if it is recursive language. All decidable languages are recursive languages and vice versa. Okay, if a language is recursive, then it is decidable. If it is decidable, then it is recursive. Partially means, it is partially decidable means if L is recursively enumerable language. All recursive enumerable languages are partially decidable. Undecidable means it may be partially decidable, but it should not be decidable language. Okay, that is, if a language is not even partially decidable, then definitely there doesn't exist a Turing machine. Okay, so undecidable means it may be partially decidable. If it is partially decidable, Turing machine will be there. If it is not partially decidable, then there is no Turing machine. Okay, so undecidable languages may be partially decidable. If it is partially decidable, definitely Turing machine will be there. If it is not even partially decidable, then there is no such Turing machine. So recursive languages are Turing decidable language, definitely Turing machine will halt for every input. Recursively enumerable languages are Turing recognizable language, it may or may not halt for input. Decidable language means Turing decidable means recursive language. Partially decidable means recursively enumerable language. Undecidable means even though it is not partially decidable also, then definitely there doesn't exist a Turing machine for that particular language. Okay.